Models of Earth. Maps and globes show the shape, size, and position of Earth's surface features. A flat model of all or part of Earth's surface as seen from above is called a map. A globe is a sphere that represents Earth's entire surface. It correctly shows the relative size, shape, and position of land masses and bodies of water. Maps and globes are drawn to scale and use symbols to represent topography and other features on Earth's surface. A map scale relates distance on a map to a distance on Earth's surface. Map makers use shapes and pictures called symbols to stand for features on Earth's surface. Usually there is a key or legend which lists all the symbols used on the map with an explanation of their meaning. Most maps and globes show a grid because Earth is a sphere, and that grid curves to cover the entire planet. There are two baselines for measuring distance on Earth's surface. These are the equator and the prime meridian. The equator forms an imaginary line that circles the Earth halfway between the north and the south poles. The equator divides Earth into the northern and southern hemispheres. A hemisphere is one half of a sphere that makes up the Earth's surface. The prime meridian is another imaginary line which makes a half circle from the North Pole to the South Pole and passes through Greenwich, England. Places west of the prime meridian are of course in the western hemisphere, while those in the east of the prime meridian are, you guessed it, in the eastern hemisphere. Using the baselines of the equator and the prime meridian, map makers constructed a grid made up of lines of latitude and longitude. Using locations of latitude and longitude, you can find any location on the Earth. The equator sits at 0 degrees line of latitude. It is a starting line for measuring latitude or the distance in degrees north or south of the equator. If you were to count the lines of latitude between the equator and the North Pole, you would have 90 evenly spaced parallel lines. Each degree of latitude is equal to about 111 kilometers. There are 360 lines of longitude that run from north to south, meeting at the poles. Longitude is the distance in degrees east or west of the prime meridian. The prime meridian, which is the starting line for measuring longitude, is at 0 degrees and are numbered up to 180 degrees. Each line represents 1 degree of longitude. At the equator, the degree of longitude equals about 111 kilometers, but at the poles where the lines of longitude come together, the distance decreases to 0. It is important to note that a degree is 1/360th of the distance around a circle. This means that there are 180 degrees in a half circle and 90 degrees in quarter of the circle. Since maps are flat and the Earth is round, map makers use map projections, which is a framework of lines that help in transferring points from Earth's three-dimensional surface onto a flat map. There are 3 common map projections used: the Mercator projection, the equal area projection, and the conic projection. Mercator projections have all lines of latitude and longitude appearing as straight parallel lines that form a rectangle. Sizes and shapes of land masses near the equator are distorted only a little, but as you get closer to the poles, the distortion increases. And this is because on this type of map, the lines of longitude do not come together at the poles. Equal area projection maps solve the problems of distortion found on Mercator projections by correctly showing the relative size of Earth landmasses. But the shapes of the landmasses near the edges of the map appear stretched and curved. They're still having a little bit of distortion. Now for the conic projection, imagine placing a clear plastic cone covering part of the Earth, then tracing the lines of latitude and longitude onto that cone. When you unwrap the cone, the piece would now be a flat rectangle, and the result would be what is called a conic projection. The projection would show the lines that you drew, and the longitude lines would be straight lines, while the lines of latitude would be curved.